Welcome to the geometry video examples. I have some various examples I want to go through in this video regarding geometry. So let's jump right in here. The circumference of a circle is 240 inches. The length of arc ABC is 40 inches. Find the measure of the angle ABC. And so geometry is one of the most interesting parts we cover in this course because shapes are everywhere and identifying how to solve them is just something so interesting about all pictures is geometry. So big thing is that we have to identify how this relationship works. And just as a couple of notes, so circumference, if we didn't know it, the formula is 2 pi r. So if you know the radius, you actually know the circumference of a circle. However, we are told the circumference of the circle is 240 inches here. This creates our formula where we have the angle over 360 degrees equal, all right, to the arc length all over the circumference. And so this equation is a ratio equation that relates length to angles. We are told we are then looking for the angle, and 360 degrees is a full rotation, right? Is the entire angle. The circumference we are told is 240, and the arc length is 40. Then cross multiply in order to solve this, and we get x equals 60 degrees. So a very, very simple little equation that can help us relate length to angles. What is the measure of an interior angle of a regular 20-sided polygon? So the general formula for the angle sum of a polygon is n minus 2 times 180. In this case, where n is the number of sides and it is 20, this gives us 20 minus 2 times 180, which becomes 18 times 180, which gives us a total measure of 33,240 degrees. Now, important notation on vocabulary here. Regular means even angles. It means each angle has the exact same measurements. So if I'm trying to find an even distribution, if the total angle is 3240 degrees, I divide that by 20 in order to find each angle's degrees, which gives us 162 degrees for each angle. Now, you know this works because, for example, a triangle, all right, is 3 sides. 3 minus 2 is 1. 1 times 180 is 180 degrees. And everyone knows that the sum of the interior angles of a triangle is 180 degrees. So this is the general formula for the angular sum of any polygon. All right, again, lots of notation when it comes to geometry. So here it says the figures are similar. All right, I want to find the measure of angle HEF and side FG. So angle HEF, that means we're looking for this angle, and side FG, that means we are looking for this. We'll call this one X. Big notes. When you have similar figures, that means all the angles on the similar figures match. Each corresponding angle will match, and each side will be a ratio. So that means dA is the same fraction to HE as DC is to HG. So if you can set up a ratio between the sides, that means you can identify the relationship of one figure to the sides of another figure. Also, the angles are exactly the same. So right here, I have angle DAB. That angle is exactly equal to angle HEF. Since DAB is 65 degrees, that means angle HEF is also 65 degrees. Similarly, notice that we have a relationship of side AB and side EF. I can then set up a relationship, specifically a ratio. Side AB over EF is exactly the same as side BC over FG. When we then plug in all that information, side AB is 15, side FEF is 6. That's the same relationship as side BC being 10 is to side FG, which we are calling X. Then again, it's just a matter of cross multiplying to solve for X, which gives us the side X equals 4, which is side FG. So again, all right, all based on the word similar. Similar triangles, similar squares, similar polygons. All right, in this case, we have some similar quadrilateral. All right, kind of looks like a rhombus. So finding the area of a shaded region is a very, very common question when it comes to geometry, because in geometry, we always, if you find a shaded region, that means you're finding lots of different shapes and then relating them. So I see many, many shapes here, and I want to relate all the pieces. The easiest way to do this is to just take it one piece at a time. So the entire area is one big rectangle that's 8 by 18. In order to find the area of a rectangle, it is simply length times width, height times length, however you want to say it. In this case, 8 by 18. That gives us an entire area of 144 square yards. Then I see basically three shapes that I want to subtract out in order to find this shaded region here. I have a triangle here, a triangle here, and a triangle here. So these two are exactly the same triangles. So we'll call those the top triangles. The general equation of a triangle is simply 1/2 base times height. The base of these triangles, and it's reversible, the base of these triangles is 4 yards, and the height is 9 yards. That makes each of these triangles 18 yards squared. So this one is 18 and this one is 18. Now let's do the area of the big triangle here. We'll just call that big triangle. And once again, same concept, 1/2 base times height. this case, the base is the entire width of the rectangle, 18 yards. The height is then also presented as 4 yards. That means the entire area of this triangle is 36 square yards. So I found each of these pieces. Now all we have to do is then subtract them out. So the shaded area is the entire area, 144, minus the big triangle, 36 yards, and each of the small triangles, which are 18 yards each. This then sums 72 square yards as the shaded area. All right, thank you very much, and I will see you in the next video.